Section 1.2, Linear Equations and Rational Equations. So a linear equation in one variable x is an equation that can be written in the form of ax plus b equaling 0. I want to point out that x has a power of 1. That's what it means to be linear, for the variable to have a power 1, for the most part, where a and b are real numbers and a cannot be 0. Now why can a not be 0? Well, if I put a 0 here, 0 times x is 0, so that would go away. So therefore my variable would be gone, and therefore it would not be a linear equation. So a can't be 0, but it can be anything else. With a and b being real numbers, we could have integers, fractions, decimals, all kinds of things. So a rational equation is an equation containing one or more rational expressions. So what is a rational expression? A rational expression, in a sense, are fractions, but fractions that have variables in the denominator. So for a rational expression, you need to have variables, like your x, in the denominator. Okay? So, example number 1, x over 5 equaling x over 6 plus 1 is linear. Linear because they have powers of 1, and even though we have fractions, we do not have any variables in the denominator. Okay? So, with a rational equation, the denominator equal to 0. So be very careful when you have denominators that have variables. When you do, you have to make sure that whatever answer you get does not make your denominator equal to 0. If it does, then you have to throw that answer out, and that answer is considered an extraneous solution. Alright, so let's try some examples. Number 1. We're going to solve and check each linear and rational equation. Write the values of the variable that make the denominator 0 for the rational equations. That's just so we can have a thought process of what values do I not want. So for number 1, x over 5 equaling x over 6 plus 1, we want to find a common denominator. And with that common denominator, we'll multiply every term by it so we can get rid of fractions. So our denominators are 5 and 6. So the first number 5 and 6 can both go into is 30. So my least common denominator is 30. Now instead of making every denominator become 30, like if we were adding or subtracting fractions, we're going to multiply every term by 30 over 1 to get rid of fractions. And as long as we do it to every single term, we're not changing the answer. So 30 times x is 30x, divided by 5, we'll just get 6x. 30 times x, but divided by 6 would be 5x. But don't forget, we also have to multiply the 30 times the 1, and we end up with 30. So at this point, it's still linear, so we're going to subtract over the 5x to bring the variables over to the same side. So x is going to equal 30. We can certainly take time to check our answers. If we put a 30 over here, 30 divided by 5 is 6. So you might want to do a check stage. Check stages are really good on the test. If you have time, check your answers. So I have 30 over 5 is supposed to equal 30 over 6 plus 1. And I want to know, is that true? Well, 30 divided by 5 is 6. Is that going to equal? Well, 30 divided by 6 is 5, and 5 plus 1 is 6. So you can certainly check your answers. I'm going to circle number 2 for you to do. In this class, you're going to have lots of examples to bring back to me from the class notes. So I want you to try number 2 before our class time. So let's try number 3. On number 3, we still have a linear equation even though we have fractions. Because our fractions do not have any variables in the denominator, this is still considered a linear equation. So our denominators are 1, 3, and 8. So from 3 and 8, what is the first number 3 and 8 can both go into? It's 24. So 24 is going to be our LCD. So we're going to multiply everything by 24 over 1. So again, when we do so, we're going to cross cancel and make our life a little bit easier. But we don't have anything that's going to cancel with the denominator of a 1, so we're just going to multiply 24 times 5, which is 120. 3 can go into 24 8 times, so we're going to have 8 parentheses x minus 2 because we'll have to distribute. Equaling, and then 8 can go into 24 3 times, so we're going to have 3 times x plus 3. So I'm going to let you finish that out, and our answer will be x equaling negative 19. Make sure you can still do the work to get to that answer. Alright, so number 4 is our first rational equation. And the reason why this one is rational is because we have a variable in the denominator. So it did say when we are having variables in the denominator, we want to make a list of anything we don't want. So here's my little thought process. What value would make this denominator 0? Well, that's if x would equal 0. We don't want that. What would make this denominator 0? Well, 0 as well, because 0 times 2 is 0. So the only value I don't want is x equaling 0. That doesn't mean this is extraneous yet. This just means that this is an answer that if I get it, I cannot keep it. So let's find our LCD. So between an x and a 2x, what's the first thing x and 2x can both go into is a 2x. We need to take the 2 because it appeared once, and we need to take the x because it appeared once. So we're going to multiply everything by 2x over 1. So with the first term, the x's cancel, and 2 times 4 is 8. In the next term, the 2x's cancel, and I'm just left with a 5. In the last term, we still have to multiply 2x times 3, and 2x times 3 is 6x. So I'm going to subtract over the 5. That would give me a 3 equaling 6x. Then I'm going to divide by 6 on both sides. So x is going to equal a half. And we can keep that answer. The only answer we couldn't have kept was x equaling 0. So x equaling a half is our answer. And we could plug it in using our calculator if we'd like and check to make sure that that actually works. And it does. Alright, so let's try number 5. We have 6 over x plus 3 minus 5 over x minus 2 equaling negative 20 over x squared plus x minus 6. So what are our denominators? They're x plus 3, there's an x minus 2, and there's an x squared plus x minus 6. So this one would factor into x plus 3 and x minus 2. Therefore, our LCD will be x plus 3 and x minus 2. Again, we'll have to take each factor that appears, the number of times it appears in one of its denominators. So the x plus 3 appeared once and once, so we'll take it once. The x minus 2 appeared once and once, so we'll take it once. And we'll multiply everything by x plus 3 and x minus 2. And that'll help get rid of our fractions. So the x plus 3's will cancel, and I'll be left with 6 times x minus 2 minus, we're going to need to figure out what we need to multiply by, which is the x minus 2 is going to cancel, so we need to multiply by the x plus 3. And the last term, both of the denominator factors will cancel, so we're just left with a negative 20. So let's go ahead and distribute. 6 times x is 6x minus 12. Distribute the negative 5, we get minus 5x minus 15 equaling a negative 20. Combine like terms, we have a 6x and a negative 5x, which gives me an x. We have a negative 12 and a negative 15, which gives me a negative 27, still equaling negative 20. Then we're going to add the 27 over to the other side, add the 27 over, so we're going to get x equaling 7. So, is that answer okay to keep? Well, let's look back at what our LCD was, which is x plus 3 and x minus 2. So in our thought process, what values do we not want? We would not want negative 3 or positive 2. If I put a negative 3 in here, negative 3 plus 3 is 0. Can't use that. If I plugged in a 2, 2 minus 2 is 0. Can't use that. And since those factored into this trinomial, we know that the values we don't want are negative 3 and 2. However, we got x equaling 7, so we're okay. But if I would have gotten, say, x equaling 2, then I would have to cross that answer out. And if it was the only answer, I would say something like no solution. If I still had another answer and that one was okay to keep, I would keep that answer. So I do want you to try another one. So this is your turn. And I want you to try to solve x over x minus 3 equals 3 over x minus 3 plus 9. So bring that answer to class with you.